and based on all these things, we want to be served what's right for us. Okay. Now we go to solution invention. Now let's come abstract again. I'm now back to my theory side of talk here. And I say, okay, we live in this. There's a current solution here. It's there. That's the red one. It's the current solution. That's what that means. And my boss comes to me and says, Eric, you're a ham tech. You're the lead technical lead. Find a problem to this solution. He says, okay, this is my knowledge boundary. This is the boundary of information that I'm aware of. And so I have this knowledge boundary that exists. And I immediately, when people come to me with problems, I don't know what it is about the human that just says, these are the constraints. But automatically, we have some presumptions about what the constraints should be, right? And there are some people that you work with that like, boom, the only solution is this thing. It's right here. That presumed constraint boundary is small, and it may not include the current solution. But that they presume that constraints exist immediately. Now these little S's here, these are all different solutions. So these solutions are solutions that would solve the current problem. It would solve the problem with the current solution. So all these solutions exist. This solution exists. It's outside of my knowledge boundary, and it's outside of my presumed constraints on the system. Which means, because it's outside, well, number one, I don't know about it. It's outside of my knowledge boundary. I'm not aware that solution exists. Number two, it's outside of my presumed constraints, so I'm likely not going to select it, right? And that's what I have to say about that one. This one, I know about this solution. It lies inside my solution space. I'm aware of it, but it lies outside of my presumed constraints, so I'm likely not going to accept it or select it because I think it doesn't meet the needs of my customer. Now this one here, this guy, he lives inside my knowledge boundary. I know about him. He also lives inside my presumed constraints, meaning I'm likely going to accept this guy. I'm likely going to accept this guy and this guy. The problem with that is that the real constraints of the problem are here. Right? And not only that the real constraints are there, but the best solution lives up here. I don't know about it. It's outside of my constraints. I wouldn't even be thinking of this thing. And if I would have selected this one, what a catastrophe. It's outside of the real constraints. It would have failed. Or would have had some major issue. So how do we push these boundaries around, right? And so that we can expand our solution space. By the way, this is why it's great to work with teams, or I can argue that it's great to work with teams, because you have a different solution space than you and you and you back there. We all have different solution space, so all of a sudden, this thing gets bigger. We have different presumed constraints. Now we start arguing, which I love to do with my friends at work, about what the real constraints are. So we start questioning constraints, and that moves this constraint thing around. And by the way, this thing, if I showed it in time, all these little blobs would be oscillating. They would all be oscillating and moving around in time. I forget, you can tell me something last week, I have no idea what it is. My knowledge boundary changes drastically every week. And my constraints change as well. I wake up in the morning, I can solve this problem. I wake up the next day, I can't solve it. I wake up the next morning, I can solve it. So, anyways, it's kind of interesting. So this guy, also he also, like Einstein, worked in a patent office. So I was recently thinking that maybe I should just quit and go work in a patent office and be one of these great people. And then I realized that there's more people that work in the patent office than just those two great people. And the probability actually of becoming a great person by working in a patent office maybe wasn't that neat. But anyways, he did it, and he recently passed away within the last, well, I guess it's just now over a decade. And his goal in Triz was to find a method, to provide a method by which people could come up with innovative solutions. So that's his art, right? And the example that he has in a book is, you have an airplane and you want to increase the speed. So you say, okay, I need a bigger motor, right? And then you make the motor bigger. But then the wings gotta have to support that motor, so they have to get bigger. And oh, by the way, the fuselage has to support the wings, so the whole thing got bigger. And now you may not have a faster plane. You've got a bigger plane with bigger motors that consumes more energy, right? So he's saying, go look for these contradictions and resolve the contradictions, and then you'll come up with some interesting ideas. And there's some books here, The Engineering of Creativity. I have it here. You can come look at it if you like. And in the Red Book, I don't own the Red Book. I ordered it recently. One of my friends said the Red Book was very useful. I think chapter 13 of the Black Book is neat. The beginning couple chapters are kind of tough to slog through, but you guys decide. You guys go and search. And so his process, I simplified his process greatly. There's like 15 steps in his, but if I throw 15 steps up here, I might get a chair. Somebody very upset with me, so I simplified it to these 5, which was define the technique, and that's really the process that you're working on. Oh, my process is to make a ham sandwich or something, right? Define the improvements, and then when you're defining the improvements, define the contradictions that keep you from making those improvements. Then he has this contradiction matrix. This is awesome. So he has this matrix, and you go look, and we'll do it. We're going to do it. And then you find these magic codes in these boxes, and you look, and you go look in the magic code section, and it says, do this! And it's incredible. I can't believe this works, right? But when you find it, because it's very silly. This guy is like the magic decoder for inventions. And it's silly to me. So he has this thing, and sure enough, you go through, and the first time you do it, you're gonna find one engineering parameter and a second engineering parameter. We'll talk about that in a second. And you go look in the contradiction method. It will tell you to do something that is completely wild, and you're like, dude, this is just wrong. And you keep trying this thing, and then you'll find maybe it's just that you should go through all his principles and then just apply them one at a time. But you apply these things, and sometimes it's like magic. It's just like amazing solutions show up to you that you weren't thinking about before, that you're like, oh, you should try to separate these things, or bringing these things together, or using design reversal techniques, or some of these other techniques. That's what he did. He looked at all the patents and he said, what did this guy do? Oh, he used reversal techniques. He used separation techniques, right? He used the harmful method, the changing a harmful problem into a benefit. So this is how he was playing, and that's how he came up with these principles. All right, so we are now Hamtech. We are the people at Hamtech. We are solving this problem. We're going to go make Jamie happy and all the other people in the world who are fighting food allergies and dietary needs, so that we can help them. We're going to make sandwiches, and the improvement is that we want custom sandwiches per the customer's diet allergy need. Formulate contradictions. So this is Mad Libs for engineering. I like to keep it very simple, because if it gets too complicated, I lose interest and I don't go anywhere. So, okay, if I improve blank, I should teach this the first period, but I never saw it in the engineering class. If I improve this thing by doing this, then this other thing will get worse. That's how easy it is. Everybody in this room can do this. My son is 2.5. I play with him about formulating contradictions. He thinks I'm crazy, but he can do it. All right. So you go to this book on page 200 and 201, and there's a magic table of engineering parameters. And if you zoom in, I zoomed in for you, you'll find that here are engineering parameters. You look up here and you say, okay, weights of moving objects, forces, speeds, tension, pressure, power, waste of substance, reliability, adaptability, convenience of use. That what he did was he tried to categorize these. He was trying to be like Mendeleev, I suppose, right? And try to categorize these engineering parameters in some kind of useful organization. I don't know. It's certainly not periodic, but it's useful. So I went through this exercise for you. You're welcome. And I said, contradiction number 1. Why isn't that restaurant meeting my need? Damn it! Why aren't they doing it? And it's really hard when you think about this problem.